dimensions in physics. And today we were supposed to look at dimensional analysis. But looking at it, there is no way we can treat dimensional analysis without treating indices. Indices is one of the foundational topics in mathematics, and we need indices as a tool under dimensional analysis. So today we're going to be looking at indices. This is mathematics today, so we're bringing ourselves to mathematics class. So in indices, basically what we are trying to do is that we want to begin to look at powers. Actually, the word indices is taken from index. Indices is a plural for index, and index number in mathematics is referred to as power. So we have the base number. For instance, if you have something like x raised to power a, the base number is x, and the index number or the power now is a. So quickly, because it's going to be a quick class, we want to look at those laws of indices that we are familiar with. And the first law, let's look at the laws. Laws of indices. Laws of indices. Now, the first law of indices, first law, number one, law one, we say x raised to power a multiplied by x raised to power b is equal to x raised to power a plus b. Please bear in mind, if you can see this well, you can see that the two base numbers are the same. This law is applicable when you have the base numbers being the same and you have multiplication in the midst of it. You can see the result. The result is that we will add the power, the index. That's that for the first law. Let's go to the second law. Now, if the multiplication is changed to division, x raised to power a divided by x raised to power b, in indices, it is said that it's going to be x raised to power a minus b. So the addition will be changed to subtraction. Now let's go to law 3, the third law. The third law says x raised to power 0 equals to 1 when x is not equal to 0. So as we say in mathematics, that any number raised to power 0 is 1 except 0, because 0 raised to power 0 is not 1. 0 raised to power 0 is 0. But any other number that is raised to power 0 generally in mathematics is 1. Now let's move to the next one. Number 4. If I have x raised to power 1, this is basic now. If I have x raised to power 1, is the same thing as x. X raised to power 1 is the same thing as x. Because most of the time, students tend to fall victim of this error. Elementary mathematics, you will know that anytime you write a letter, that letter is raised to power 1. That power of 1 is invisible. Now let's move to 5 now. Law 5. We have that x raised to power a, and if you apply the bracket, times b is going to be x raised to power ab. Now, if you have it this way, you are going to multiply the power. This ab means a times b. Let's move to 6. Law 6, x raised to power minus a. This is more of what will happen when you have negative power now. Anytime we have negative power, what we do is that that negative sign becomes the reciprocal, 1 over. So we bring the remaining x raised to power a to the denominator, so that x raised to power minus a becomes 1 over x raised to power a. As you can see here, that minus has been used for this 1 over. So I'm no longer repeating the negative sign here. And let's move to the next one, 7. Law 7. If I have x over y raised to power a, all raised to power, because I put the 2 in bracket now, So what is going to happen here is that they will both share the power x raised to power a over y raised to power a. These laws are like templates that we use generally in mathematics. Let's look at law 8 here. If I have x raised to power a over b, at this point, you have to take note. X raised to power a over b, this is a fractional power. In fractional power, you have the numerator as a now, and you have the denominator as b. Now, if you look at it here, the numerator here, I call it the power. The denominator, I call it the root. So that is how you are going to write it. The numerator is the power, the denominator is the root. So x raised to power a over b is going to be x, and the root is b. Bear in mind, b root of x. You can put everything like this in bracket, raised to power a. You can see b is the root, the denominator, that's the root, and a is the power. This is what happened. You can as well have negative here. What will only happen is that you are going to repeat what we did here, 1 over, and the rest of it will be like the same. These are the 8 laws we are going to talk about, and we are going to be moving to some exercises and some calculations on indices. So it's very necessary we understand these laws, because we are going to be making use of these laws in our calculations in a GV. To the exercises, we are going to start from simple ones, and as you can see, we have exercises from A to L. So I'm going to do some, then I will leave others for you viewers to also try. Now, if you can see, we have just run through the laws of indices, and for these questions, we're going to be using law between law 1 to law 5 now. We're going to be using between law 1 to law 5. So the first question A says 5 raised to power 2 multiplied by 5 raised to power 4. So the base numbers are the same, just as the base letters are the same here. So the first law says that once we see question like this, we add the power. So we write one of the base, 5, 2 plus 4, and that is 5 raised to power 6, and that is that about the first question. So let me leave B for you viewers, and let's come to C. If you look at C, this is having a negative power. It's having a negative power. Base numbers the same. So we are doing the same thing here. It's going to be a raised to power 6 plus minus 3. Plus minus 3. And anytime we have positive and negative, it's negative that we always dominate. That's sure. So this is 6 minus 3. And so this is a raised to power 3. So it is the negative that will dominate. Now let's come to E. So let me leave D for you viewers to also try. So if we come to E, you can see we're referring to the second law now. There is division there. So this is m raised to power 15, same base m. Then when it's division, the rule says we should put negative in the power. So minus and another minus 3. So this is not 3, this is minus 3. So minus minus, when we have two minus sign, it becomes positive. So we have m raised to power 15 plus 3 now, and that is going to be m raised to power 18. Now if you come to G, so you have another one to try here. If you come to G, you can see that we're looking at the fifth law, law 5 there. So it's saying that we should just multiply the power. That means we're going to say P raised to power 48. And that's the answer there. Let me solve this H, question H. So you can see that we still have the same base number now. Multiplication here, division here. So that's going to be 3 raised to power 5 plus 6 and minus 2. And so it's going to be 3 raised to power 5 plus 6, 11. 11 minus 2, that is 9. 3 raised to power 9. So I'm going to allow you to do I, and let's come to J. Let's come to J. You can see we're still doing the same thing. So depending on how I want to solve it anyway, I can decide to first of all treat the division. We still have the same base number. So y raised to power 8, I will say minus 4, then I will raise everything to power 5, just as it's there. So this is y raised to power 8 minus 4 is 4, and I have 5. That is y raised to power 20. So with that, let me leave k for you, and I solve the last one. You can see. So let's treat the numerator first. That is j raised to power 4 plus 8, as you can see at the numerator. Solve L now. For L, as you can see, you have j raised to power 4 at the numerator, j raised to power 4. So the base number are the same, jj, so we can say 4 plus 8, and at the denominator we have j raised to power 9, and this is division. Law 2 says we should subtract minus 2, and all raised to power 3. And this is j raised to power 12, that is 4 plus 8, 12, and divided by j raised to power 9 minus 2, and that is 7, all raised to power 3. I can treat this division now as the division of this form is still the same. So when you have division in between the two base numbers, you can see j and j. So this will be j raised to power 12 minus 7. Because of this division sign, 12 minus 7. It is this division sign that is working for that minus now. Then I will have raised to power 3. So this is j raised to power 5 and 3. So this is 5 multiplied by 3 now, not 5 raised to power 3. So it's going to be j raised to power 15. And that is the end for this quick class. Next, we are going to look at questions that are a little bit harder than this, especially where we're going to make use of from law 6, 7, and 8. And that is how I think we should go.